Hey guys, what's up everybody? Welcome or welcome back again to another video tutorial from the Apex Academy of Mathematics. We are learning the language of the universe begins here, and in this video we are going to be talking about the application process of using the elimination method and or the substitution method in a variety of different types of questions, both worded and questions that are already created for you. Alright, now my name is Akin, otherwise known as Apex Selenio, and of course if this is your first time here on my channel, please of course do me the favor of smashing the like button, of course smashing that subscribe button and turning on your post notification bell for future video tutorials on mathematics. Okay, alright guys, so of course without further ado, let's jump right into the video. And of course this is going to be a little bit of a lengthy video, so do ensure that you have enough time on your hands to watch this, because what the objective of this video is to make sure that we go through all different simultaneous equation, all different structured questions, and of course giving you the best value. And of course if this is your most feared topic or one of the most talked about topic, this video is the one for you to watch, because of course you're going to get the best benefit here. All right, so hope of this video you're going to master and understand all the different types of simultaneous equations that there is. Okay, so let's get right into it. Alright, so the first question here is asking us here to solve the simultaneous equation 5x plus 3y equal 41 and 2x plus 3y equal 20. Now for this particular question I'm going to be using the elimination method, right? And here's the reason why I'm going to be doing that. Number one, none of the coefficients of my variables are equal to 1 or minus 1, so that eliminates the thought of me even using the substitution method. Secondly, using the elimination method when the variables are the same, like this one, is of course quickly prevents me from using or creating a third and a fourth equation, which is the norm for solving most simultaneous equations. So once I can see a setup like this one where both of the variables of any one of both of the coefficients of any one of my variables are the same, then that kind of suggests to me that the easiest process here is to use the elimination method. All right, so before I jump into it, I need to make a note that of course same signs, let me just write that here, same signs implies that I need to subtract, and different signs implies that I need to add. Alright, so we need to make a note of that specific thing right there. Okay, so just to make a note of that. Alright, so let's get right into it. So here we have, first we're going to name our equations as we have always been doing. Alright, and then now because I recognize that I do not need to create a third or a fourth equation, I can just go ahead and subtract equation 2 from equation 1, and that will imply that I will get 5x minus 2x plus 3y minus 3y, and that's equal to 41 minus 20. Okay, good. So 5x minus 2x, that's going to give me 3x, and of course 3y minus 3y, that's going to give me 0, and 41 minus 20, that's going to give me 21. So if I divided both sides by 3, then clearly I'll get a nice result for x, which is going to be equal to 7. Right, so my x here is equal to 7. So naturally now what I'm going to do here is that I'm going to substitute the number 7 that I found for x, and I can choose either equation 1 or equation 2. So I feel like I want to use equation 2. The numbers are a little bit smaller and easier to manipulate. Okay, so I'm going to have 2 times 7 plus 3y, and that's going to be equal to 20. So 2 times 7 is 14 plus 3y, and that's going to be equal to 20. So if I subtract 14 from both sides, I'm going to get 3y, that's going to be equal to 20 minus 14, so 3y, that's going to give me 6, and if I divide both sides by 2, I'm going to get y to be equal to 6 over 3, so y is going to be equal to 2. Alright, so that gives me the result that I have there. Alright, so apologize for jumbling up the working out a little bit here. I'm gonna try to be a little bit neater in the questions to come. Alright, so that kind of takes care of that question. Let's now kind of scroll up now to the second question here. Alright, lovely. So I'm just going to change up with stuff here. Okay, here we go. So now we're asked to solve the pair of simultaneous equation 5x plus y is equal to 11, 3x minus y is equal to 9. So in this example here, I have a choice. I can use between the elimination method and the substitution method. And again, guys, this comes down to personal preference. All right. Now, in this example here, I am going to be using both methods to show you that it both works. Now, why is it that I can use the elimination method? Like the previous example, I have one of my variable with the coefficients being the same. So here I have a plus 1 and I have a minus 1. They don't have the same signs, but they have the same number in terms of like the digit itself. So we have a rule here that helps us to deal with the signs a bit later. Same signs we subtract, different signs we add. So with that rule now, we can ignore the signs and pay attention to the fact that the coefficients of the y's are the same. So that suggests to me that the easiest method to use here is of course the elimination method. But also recognizing here that one of my coefficients of my variables have a coefficient of 1 or minus 1 also suggests to me that I can use the substitution method. Alright, so this comes down to personal preference, and of course most teachers here will tell students that it's best to use the elimination method, which of course I have absolutely no problem with. So I'm going to be demonstrating both methods here for you. Alright, so here we go. So for the elimination method, I do not need to create a third and a fourth equation. I simply recognize here that the coefficients are already equal, and because the signs are different according to the rules up here, if different signs, we're going to add equation 1 to equation 2. So I have equation 1 plus equation 2, and that implies that I'm going to have 5x plus 3x plus y plus negative y, and that's going to be equal to 11 plus 9. So 5x plus 3x, that's going to give me 8x, and y plus negative y, that's the additive inverse identity, that's going to give me 0, and of course 11 plus 9, that's going to give me 20. Seems as if I'm going to get a fraction here for my answer. So I have 8x divided by 8, and that's going to be equal to 20 divided by 8. So when I cancel that out, x is going to be equal to 20 over 8, which its equivalent is that x is equal to, say, 4 into this goes 2 and 4 into this goes 5, so its equivalent is 5 over 2. Alright, now I can simply here go ahead and now I can substitute 5 over 2 for x in, and I can choose, I like equation 2, even though the negative sign is there, which I don't necessarily encourage, because it always just, you're already this close to getting your 2 answers or your final answer, and then a sign could give a lot of students trouble. So I always encourage just to use equations that have positive and have the smallest number, unless you have unless you don't have a choice, then you do that. So for this one, no matter, I'm going to be using equation 2. Okay, so here we have 3 multiplied by the value of x here is 5 over 2, and that's going to be equal to, I'm sorry, let's just erase here, that's 3 times 5 over 2 minus y, and that's going to be equal to 9. Okay, so 3 times 5 is actually going to be equal to 15 over 2 minus y, and that's going to be equal to 9. Okay, now I need to get the y to be a positive. So if I subtract 15 over 2 from both sides, my y will still be negative. I think there's an easier way of doing this where I can simply add y to both sides. So adding y over here disappears, and adding y over here gets my y to be positive. So while I'm adding y to both sides, I'm subtracting 9 from both sides. So let me just write that down, let you see what that looks like. So we are going to have 15 over 2 minus y plus y, and that's equal to 9 plus y. That brings me to the first part. So these two cancel out. So I'm going to get 15 over 2, and that's equal to 9 plus y. Okay, so that's what I mean by adding y to both sides. Of course, I do have some videos on my channel introducing you to equations, so do also check that out. So I'm just going to just erase this here to give me some space. So pretty much when I add y to both sides and subtract 9 from both sides, I'm going to have y is equal to y is going to be equal to 9 minus 15 over 2. So now working this out, I have y is equal to 18 minus 15 over 2. So this works out nicely to that y is equal to 3 over 2. Okay, alright, so this is fraction, so it's just basically the LCM is 2, and 1 into 2 goes 2, 2 times 9 is 18, 2 into 2 is 1, 1 times 15 is 15, so we get nicely y here is equal to 3 over 2. Alright, so hopefully you guys got that that unexpected fractional question here, but we know that it exists, so let's not worry about that too much. Alright, so that's for that part. I am going to erase this here so I can use the substitution method to show you that you're gonna get the same answer, right? Because I really want to demonstrate the application of why and when we use each method and which is best based on personal preference. So for the substitution method here, I am simply going to say from, okay, so hold on here, I'm going to say from equation 1, I'm going to make y the subject. So making y the subject, I need y to be alone on one side, so I'm going to subtract 5x from both sides. So that's 11 minus 5x. Okay, alright, good. So hope you got that. I'll just bring that 5x over to that side here. Okay, good. So now I'm going to sub 11 minus 5x for y. Obviously I used equation 1 to create equation 3, so obviously I'm gonna have to substitute this value in equation 2 for y. So I'm gonna have 3x minus the value of y, and in this case the value of y is 11 minus 5x, and that's going to be equal to 9. So I'm going to have 3x minus 11, negative multiplied by 11, negative 1 multiplied by 11 is negative 11, negative 1 times negative 5x, that's going to be equal to positive 5x, and that's equal to 9. Okay, so now grouping like terms, I'm going to have 3x plus 5x, and that's equal to 9 plus 11. So I'm going to have 8x is equal to 20. So you see I end up back with the same one I had before. So if I divide both sides by 8 by reduction, I'm going to get x is equal to 5 over 2. Alright, so now in this case, now I'm just going to substitute 5 over 2 for x, but this time putting it into either equation 1 or 2 is a lot harder than substituting it in equation 3. Why? Equation 3 already has y as the subject, so to find the value of y, it's just a matter of just substituting the 3 for x. So 11 minus 5 times 3, well, substituting 5 over 2, I'm sorry, not 3 but 5 over 2. Alright, so I have here y is equal to 11 minus 25 over 2. 5 times 5 is 25 over 2. And then easily now I can have y is equal to 22 minus 25 over 2. Okay, and now I have y is equal to negative 3 over 2. Alright, so I hope you guys got that part. Alright, so these are my two solutions here. Y is equal to negative 3 over 2 and x is equal to 5 over 2. All right, so that was the beginning part of the question. I did apply question elimination and substitution method to this very same question because of course in questions to come I'm just going to be picking a method that I think is most suitable to get the answer the most effectively and the fastest and basically the smoothest. Yes, so it all comes back down again, guys, to personal preference. But of course there are questions out there where the elimination method is not applicable, so it's good to also practice your substitution method. All right, so we're going to go across now to question 3 and see how we can get this question done here. All right, so what we have here is to solve the simultaneous for an x plus 3y is equal to 28. All right, so naturally, guys, what we're going to be doing here is that we're going to be using we're going to be naming our equations as per usual. So this is basically equation 1 and of course this is equation 2. All right, lovely. So now what method am I going to use here? I am going to be using the elimination method. Why am I using the elimination method? Of course I already have a variable with a coefficient of 1. All right, so right here and then, because they are already the same, it's quite easy for me to say I'm just going to subtract equation 1 by equation 2, or subtract equation 2 from equation 1. Okay, so that implies that I'm going to have x minus x, I'm going to have plus 7y minus 3y, and that's going to give me easily 64 minus 28. Okay, so x minus x obviously disappears, and 7y minus 3y, that's going to give me 4y, and of course 64 minus 28, that's going to give me 36. So if I divided both sides by 4, it's going to easily come out that y is equal to 9. Okay, so that wasn't such a difficult question at all. All right, once you made the decision as to what method you're going to be using, so now easily now all I have to do now is just substitute 9 for y in, and it's just a matter of just choosing the equation that you most feel comfortable with. Again, I'm going to be using equation 2, reason being the numbers are smaller and more easy to manipulate. Okay, all right, so now I have here, I'm just going to say, since y is 9, I'm going to have x plus 3 times 9 is equal to 28. So I'm going to have x plus 27, that's equal to 28. So subtracting 27 from both sides, x is going to be equal to 28 minus 27, and x is going to be equal to 1. So that was not a bad answer. All right, not a bad working out. So you can see so far in the first examples, we have been exposed to quite a different ways the question can be set up. Here in this example, we found y before we found x. In previous examples, we found x before we found y. In another example, we had a choice between using the simultaneous elimination method or the simultaneous substitution method, and so forth. So far already, guys, after about 20 minutes being at this, we have been exposed to quite a variety of questions. So let's see what more this has to offer us here. So now what we have now, guys, is to solve another simultaneous equation here. This is 4x minus 4y is equal to 24, and x minus 4y is equal to 3. All right, so this is equation 1, and of course this is equation 2. So what method am I going to use here? All right, so in this case, guys, I also have a choice, but here I'm just going to make a personal preference. Now let's explain the two choices and why they're open for you to use. Here I easily recognize that the coefficient of my y's are already the same. So because they have the same signs, all I have to do now is just to add both equations, and I will get my value of y in a linear form and solve. All right, but for this example, what I also recognized is that one of my variables has a coefficient of 1. So I could also use the substitution method, which is exactly the method I'm going to be using here, but I don't mind, of course, doing the second method for you too, so you can see its application. Okay, so but for this question I really like the substitution method, so I'm going to go with that one for the first part. So I'm going to say from equation 2, x is equal to 3 plus 4y. All right, guys, a lot of persons ask me all the time when I'm teaching, sir, how did you get that part here? And sometimes they miss it here. What I did, guys, is that I simply just brought over the 4y over here. So because the negative 4y comes over the equal sign, it becomes a positive, or easier said is that I added both 4y to both sides. Okay, all right, so here we have this third equation here that we're talking about. All right, so here now we're going to sub 3 plus 4y for x. Obviously we're going to put that in equation 1 because we used equation 2 to create equation 3. So putting back equation 3 into equation 2 is just going to show you that they are the same equation. So it's just going to equate both sides basically. So put it back in equation 1. So what we have here is just since it's for x, it's going to be 4 open bracket 3 plus 4y, and that's going to be minus 4y equal 24. All right, for some students this may look a little bit longer, but it's just a personal preference of mine. I do encourage, if you are to see this kind of question in an exam, if you're not very versed on using the substitution method, by all means go ahead and use the elimination method. All right, just a personal preference, guys. So 4 times 3 is equal to 12, and 4 times 4y is equal to 16y minus 4y, and that's equal to 24. Okay, so now I'm just going to subtract 12 from both sides. So I have 16y minus 4y, that's going to give me 12y, and I'm going to be subtracting 12 from both sides. So I have 12y is equal to 12. So if I divide both sides by 12, I'm going to easily get that y is actually equal to 1. So y is equal to 1. Okay, so that works out for us there. So all we have to do now is simply sub 1 for y in equation 3. Why equation 3 and not equation 1 or 2? It works for equation 1 or 2, but it's easier to find it for equation 3 because x is already the subject. Okay, so we have x is equal to let's see what equation 3 is. 3 plus 4y, so that is 3 plus 4 times 1, so that's x is equal to 3 plus 4, so x is equal to 7. All right, so that works out for that question. All right, so clearly you can see it's not that big of a deal when it comes to using the substitution method. Hopefully you're getting it, guys, but of course I really still want to not leave you empty-handed. For those who are saying, hey, I'd like to see how this question pans out with using the elimination method, I have no problem in doing that for you. So we got x to be equal to 7 and y to be equal to 1. Let's use the elimination method to get the same answer here. So that's equation 1 and equation 2. They are already the same, the coefficients of the y, so I'm just going to add equation 1 to equation 2. So equation 1 plus equation 2, that implies that we're going to have 4x plus x minus 4y plus negative 4y, and that's going to be equal to 24 plus 3. Okay, so this is 5x here, and we're going to cancel these out because they are the additive inverse identity of each other. All right, that's the result, and 24 plus 3 is 27. All right, so let's see here. Actually, we cannot add, guys, the same signs. Let's go, if we go back to the rules, it says same signs we subtract, so that's my bad. So here we're going to subtract here, so we should, instead of having 4x plus x, we're going to have 4x minus x. All right, forgive me guys for that error. And then we're gonna have 24 instead of plus 3, we're gonna have 24 minus 3, so that's gonna give me 21 here. Okay, and there we have it. X is equal to 21 divided by 3. X is equal to 7. So that's what we got earlier. X is equal to 7. All right, so we're just going to sub 7 for x in, let's choose equation 2. Okay, so we have x minus, okay, x is 7 obviously, so 7 minus 4y, and that's equal to 3. So what we have here is simply we can add 4y to both sides, so we have 7 minus 3, so add 4y to both sides, subtract 3 from both sides, and that's equal to 4y. Okay, so what we have here nicely is that 4 is equal to 4y, so we have 4 over 4, that's equal to 4y over 4, dividing both sides by 4. And easily now what we have guys is that 1 is equal to cancel out y, which is exactly what we got before. So clearly you can see guys that, again, as I said, this is all personal preference. It's just what is easier for you as a student, what best you understand. But you need to know both methods, because of course there are questions, for example the simultaneous quadratic equations, where the substitution and the elimination method, pardon me, is not applicable. All right, so let's proceed into continuing with a few more questions here guys. So right here and then, now that you've seen when and where and how and why I apply each method, for the remaining questions of this video guys, I'm just going to just pick a method, work with it according to how I feel the question is needs to be worked out. All right, so you can follow along or you can experiment by using the opposing method. So for question 5 guys, what we're gonna have here is just equation 1, equation 2. So for this now guys, I see an opportunity here to use the elimination method. Reason being, the two coefficients of the y variable are the same, so that suggests to me that I have different signs. I'm pretty much going to just add to eliminate. Okay, so I'm going to be adding equation 1 to equation 2, so that implies that I'm going to have 2x plus 4x plus 4y plus negative 4y, and that's going to be equal to 14 plus 4. Okay, so 2x plus 4x is 6x, and of course this is the additive inverse identity. 4y plus negative 4y is 0, and of course 14 plus 4 is going to give me 18. So if I simply divide both sides by 6, I'm going to easily get x to be equal to 3. Okay, so that did not take too long to work out. All right, and I'm sure that by you get to this level, you should be able to work the question as fast and as efficiently as I just did. Okay, so now I'm going to substitute 3 for x in. I'm going to choose equation I like equation 1 because the numbers are smaller. All right, and it has a positive, no negative, so it's easier for me. So I'm going to choose equation 1. Okay, so equation 1 is 2x, and that's, since x is 3, it's going to be 2 times 3, and that's going to be plus 4y, and that's going to be equal to 14. Okay, so this is 6 plus 4y, and that's equal to 14. And I'm going to subtract 6 from both sides, so I'm going to have 4y subtracting 6, that disappears, and then I'm going to subtract 6 from over here. Okay, so I have 4y, that's equal to, easily that's going to be 8, and if I divide both sides by 4, I'm going to get y to be equal to 2. So y is 2 here. All right guys, so hope you guys got that question so far. So we're just going to scroll right along now to question 6. So we are meeting up for the first time our worded questions. Now of course I am from the Caribbean. of course I'm teaching simultaneous equation regardless of how it may be set up, but here the questions that I have is of course written in pounds, and sometimes you may see a question here written in pence. So just to make a note for the future here, right over the corner here, that since 100 cents is equal to $1, okay, then it means that 100 pence is also equivalent to £1. Okay, so just in case you meet upon that, just remember that it's the same different currency, but it's the same mathematics right behind it. Okay, all right, so let's just take this off here so you recognize here. So don't watch the pound, just imagine if you're working a question with dollars and cents. Okay, all right, and if you're in England and you're watching this video, then of course you should be okay with this. So for this question, guys, when you get a worded question, you just simply want to assign a letter to the quantities, or the quantities that are being sold, not the quantities but the products that are being sold. My apologies. So here we're selling DVDs, or David is buying DVDs and CD, and so is Ellie. All right, so it doesn't matter what letters you use, it's just your personal preference. Of course, the norm or the tradition is to use X and Y, which I'm going to be sticking with in this question. So I'm going to be calling all my DVDs X, and I'm going to be calling all my CDs Y. Okay, so David, then here's David's equation. David said he's going to buy 2 DVDs, so he's going to buy 2 X's, and he's going to buy 2 CDs, he's going to buy 2 Y's, and when he bought them, it cost him a total of £18. Okay, so that is the first equation. Ellie now decides to buy 3 DVDs, so she's going to buy 3X, but she's also buying 2 CDs, so 2 Y's, but that cost her, of course, £22. Okay, so if that's the case, then we have created our own equations. So just look at it now, and we can see that here's an easy opportunity for the elimination method here. So we're just going to subtract both equations. So we're going to say equation 1 minus equation 2, simply because these two coefficients are the same. All right, and the signs are also the same, so that implies that we're going to have 2x minus 3x. Okay, and that's going to be plus 2y minus positive 2y, which is minus 2y, and that's equal to 18 minus 22. Alright, so 2x minus 3x, that's going to give us negative x, and 2y minus 2y is 0, and 18 minus 22, that's going to give us negative 4. So we can divide both sides by negative 1. So dividing both sides by negative 1, we're going to get x is equal to 4. All right, and in this case, it's gonna cost David £4 for a DVD. All right, we're gonna proceed now by saying we're going to substitute for 4x, and we can choose either equation 1 or 2. I like equation 2 because equation 1, pardon me, because the numbers are smaller. All right, that's just a personal preference, but equation 2 is works just as well. All right, so I'm going to choose equation 1 here. And so we're going to have here, let's write a bit smaller for you here. We're going to have 2 times the value of x, which is 4. We're going to have plus 2y equal 18. All right, guys, I'm using this equation right here, this one right here. Okay, all right, good. So we have 8 plus 2y is equal to 18. Subtracting 8 from both sides, we're gonna have 2y is equal to 18 minus 8. So 2y is actually equal here to 10, and if we divide both sides by 2, we're easily gonna get that the cost of a CD is equal to £5. Okay, so the cost of a CD is £5, cost of a DVD is £4. Okay, so do expect worded type questions that you may see in textbooks and exam papers. All right, guys, so hopefully you guys are getting the content so far. Oh, this was Ellie's equation for those who are wondering. Okay, so that was Ellie's equation. All right, guys, so we are going nicely along, guys. So let's see if we can see any more questions that may give us a bit of challenge. All right, so here we have two more nice questions here. Let's see how they plan out. Alright, so what we have here, guys, is simply 2x plus 4y is equal to 26. That basically is going to be my equation 1. And this is equation 2, which is 3x minus y is equal to 4. So here we go, guys. What method can I use here? Alright, so for this one, guys, again, as I mentioned, I'm not going to stop repeating. This is a personal preference. A lot of teachers will tell you to use the elimination method here for the fact that it's easier. All right, but for this one, I feel like I want to use the substitution method for that reason. The reason for that is because, of course, I have a variable here with a coefficient of -1, so I can make this letter here, this variable here, my subject. All right, so I can say from equation 2, I'm going to add y to both sides. So I'm going to bring this y over here, and I'm going to bring this 4 over here. So I'm going to get 3x, and I have 4. I bring this 4 over, I'm going to get -4, and then I'm going to have a positive y. So that creates my third equation here, and I kind of like that method, all right, because already I have an equation which makes me find the value of my final variable a lot easier. All right, and this is just, again, guys, personal preference. Okay, now I'm going to substitute. All right, 3x minus 4 for y in, of course, equation 1. Okay, so I'm going to use these equations for my substitution right here. So I'm substituting that for y, so I'm going to have 2x plus 4 times 3x minus 4, and that's going to be equal to 26. Okay, so 2x plus distribution law here, 4 multiplied by 3x is going to give me 12x. 4 multiplied by -4 is going to give me -16, and that's equal to, of course, 26. Okay, so two like terms here. I can have 14x here, and I can add 16 to both sides. So I'm going to get, when I add 16 here, it disappears, but when I add it over there, I'm going to get 26 plus 16. Okay, so I have 14x is equal to 42, and obviously x is going to be equal to 42 divided by 14. Dividing both sides by 14, x works out to be 3. Okay, all right, so easily now, guys, I can just go over here and I can say, hey, I'm going to substitute. Okay, not spelling that word correctly, so I'm going to substitute 3 4, what am I substituting? 3 for x. Okay, in, of course, naturally I'm going to be using equation 3 because I already have it as y being equal to this. So y is equal to, I'm just going to rewrite it all the way, y is equal to 3 times the value of x, which in this case is 3, minus 4. So y is equal to 9 minus 4, y is equal to 5. Alright, so I'm getting some nice, lovely answers here. Alright, guys, so I hope you guys are catching the drift. Of course, if you are not getting why I'm choosing these methods on a specific purpose, please, of course, go right ahead and check out my other videos. The links are in the description below for the videos explaining what the substitution and the elimination method is. I have videos breaking down the steps, the steps in pieces, and of course both for elimination and substitution method. So do check out that video also, and then you can return here to run through these exercises with me, guys. All right, so I'm just going to pretty much just go through one more question, then I'm going to create the part 2 video for this, because there are about 12 more questions that I'd like to expose you to. All right, this is really a sit down practice video that you need as a student. All right, so after watching this, I it's highly unlikely that you're going to ever have a problem with simultaneous equations again. So here's the final question for this video. So here what I have now is equation 1 and equation 2. So this is the first example that you guys are going to see where I'm going to be creating my third and my fourth equation. All right, and this is what typical simultaneous equations normally look like, where you have to create a third and a fourth equation. Okay, all right, so guys, we need to choose numbers to multiply the equations by, so that either the coefficient of the x variables are the same or the coefficients of the y variables are the same. At the moment we have 3 and 2 as the coefficients for the variable x, and we have 2 and minus 3 as the coefficient for the variables y. Now there is a tradition for most math teachers all around, no matter where you're from, that it's always best to stick with the tradition of equalizing the coefficients of the middle variable. All right, but you can also experiment by equalizing the coefficient of the first variable. In other questions to come, I'll demonstrate that for you, but for this one I'm going to stick with the tradition of equalizing the middle coefficients of the middle term. Okay, all right, so what number do I choose to multiply equation 1 by and 2 by? And a lot of students have a lot of problems with this. All right, they just choose a random number, or sometimes you just get really confused and not know what to do. So here's what I'm going to teach you: the interchange coefficient technique. Do check out that video. I have a link in the description below, so check out what that means. So what the interchange coefficient technique is that if I decide I'm going to equalize the middle coefficients, I'm going to take a look at the coefficient for this y, and I'm going to multiply this equation down here by that number. And here the coefficient here is minus 3. I'm just going to ignore the sign because I have a rule to help me deal with the signs. So I'm just going to look at the 3 and I'm going to multiply this equation up here by 3, and that works like magic. It works every time. Once you do that, you're going to always get these two numbers or these two numbers to become the same. Alright, so let's see how that pans out. So 3 times 3x, that's going to give me 9x, and 3 times 2y, that's going to give me 6y, and 3 times 16, that's going to give me 48. So that creates my third equation. Alright, now the next one now is 2 times 2x, that's going to give me 4x, and 2 times minus 3y, that's going to give me minus 6y, and 2 times 2, that's going to give me 4, and that's equation 4. Alright, so if you notice here that these numbers that I've chosen by using the interchange coefficient technique causes these two numbers to automatically become the same. It works like magic every time. So finding these numbers is never going to be a problem. You can just simply use the numbers that you already have here. Sometimes choosing those numbers sometimes gives you a bigger number that you have to work with, but the point is that you really want to get to your answer. Yes? Alright, so let's get to it. Now let's check if the signs are the same or are they different. Well, if they are different, then we're obviously going to add to eliminate. So we're going to be adding to eliminate. So equation 1, okay, not equation 1, but this time it's equation 3 plus equation 4, and that implies 9x plus 4x plus 6y plus negative 6y, and that's going to be equal to 48 plus 4. So adding these two, I'm going to get 13x. Adding these two, additive inverse identity, I'm going to get 0, and adding those two, 48 plus 4, it's going to give me 52. So if I divide simply both sides by 13, I'm going to get x to be equal to easily 4. Okay, so x is equal to 4. Alright, so now what I'm going to do here is that I'm going to substitute 4 x in, I can choose equation 1 or 2. Alright, so I can choose equation, I like equation 1 for the fact that this is negative and I do not want to mess myself up at this stage, so I'm going to choose equation 1 here. Okay, so now what I have here is simply 3 times the value of x here is 4, so 3 times 4 plus 2y, and that's going to give me 16. So 12 plus 2y That's going to give me 16. I'm going to subtract 12 from both sides, so I have 2y is equal to 16 minus 12. So 2y is equal to 4. 16 minus 12 is 4. And if I divide both sides by 2, I'm going to get y is equal to 4 over 2. So y works out nicely to be 2 here. Okay? And that gives me my final answer for this question here. Alright, so hopefully you guys are following so far, and of course if you need to watch the video again, do take the time out and spend some time to master your chat. This topic has always been requested by my students that they're having problems, so hopefully this video is able to help you to go through that. Alright, so guys, I'm going to pick up in part 2 on question 9, and there are more little variations that I really want to allow you to see, so do pick up the next video next. All right, do not click off this channel, take a break, drink some water, have a juice, eat a snack, and return back to this video for the remaining tutorial. Do take care until next time. My name is Hakeem, and don't forget to subscribe and turn on your post notification bell. Take care, see you next time, bye bye.